Thank you very much, Uwe. Our third panelist is Professor Michael Eineder. He's directing the Department of Synthetic Aperture Radar Signal Processing at the Earth Observing Center, part of the German Aerospace Center, DLR. So the DLR is Germany's National Aeronautics and Space Research Center, and Professor Eineder will summarize DLR's contributions to satellite remote sensing in the Arctic. Please.
Thank you very much for the introduction. Distinguished guests. The German Aerospace Center is developing and operating remote sensing satellites in space, and we are doing research with the data. In my talk, I will focus on radar satellites. These are satellites that circle around the Earth every 90 minutes on polar orbits, and they can take images at every daytime and nighttime and at any weather conditions. Therefore, they are especially suitable to monitor the Arctic environment. At DLR, we are engaged in the whole information chain from the satellite to the user. In the following, I will show some recent developments. A remote sensing satellite generates a huge amount of data, and before we can use it, we have to bring the data to the ground. For this purpose, DLR operates several receiving stations worldwide, and additionally to this, we cooperate with international receiving stations to optimize our access to the satellites. In the map, you can see the satellite visibility around each of our receiving stations. Within this visibility area, we can receive satellite data, images, and we can react immediately. Another topic. DLR invented the Tandem-L mission, a very innovative satellite mission that consists of two radar satellites. Both work together to get a stereo view of the Earth's surface. From the data, we are currently generating a global digital topographic map of the Earth. Especially in the Arctic, this is definitely the most accurate map that is currently available. Radar images are a very accurate and reliable measurement tool, and we can observe some essential climate variables. Here you can see a one-year time-lapse, a video of a glacier discharging into shelf ice. Such an all-year observation can only be done with radar satellites. When we analyzed the data, we found a massive acceleration of the ice velocity within 10 years. But you may have noticed that this glacier is not located in the Arctic, it is located in the southern hemisphere. We have other results here in Greenland. In the recent years, we cooperated with the University of Washington in observing the Greenland glaciers with our German TerraSat satellites. Also here, we found a massive acceleration in ice discharge, especially during the summer months. But remote sensing data are not only valuable for science. We have now currently an initiative in Germany to use satellite data in near real time for safety and security on oceans. For example, we can detect oil spills on the water, we can see if a ship is endangered by floating icebergs, and we can help to find routes through the sea ice. So, what for the future? What could be better? And this is our proposal that we have currently, a DLR proposal for the next radar satellite mission, a national mission. That's also composed of two satellites, the Tandem-L mission. And one of the goals is to provide a frequent and global update of many essential climate variables which are relevant for observing the ice caps, for glacier flow, and for monitoring permafrost. Thank you very much for your attention.